Our final measure of dispersion is going to be variance and standard deviation. Variance and standard deviation are part of the same process. The variance and standard deviation are used with numeric level variables only, and the variance represents the average deviation or distance from the mean. So how far away is the average respondent? 0 is the smallest value that the variance can have. This means that there's no variation. So all the observations are the same. All the respondents gave the same answer. The greater the variation about the mean, the larger the variance will be. So the more difference there is in the way that people respond, the higher your variance will be. There's no top limit to what the variance can be, and so it can be really anything. I've seen variances all the way up into the thousands. So how do we go calculating the variance? The equation for variance is the sum of x minus the mean squared divided by n minus 1. So what this equation is telling us to do is to take every x, or every data point, subtract the mean, or the average for all of the data, square those, add each one together, and then divide by n minus 1. So to start with our equation, we're going to need to calculate the mean. That's going to be our first step. And if you'll recall, the equation for the mean is the sum of x over n. And so in this case, we're going to go over to our data. We're just going to put a little plus sign here. We're going to add all of those together, and that's going to give us a total of 200. So our sum of x is 200, and we're going to divide that by n, and we have 10 data points here, so we're dividing by 10, which is going to give us 20 as our mean. So we want to go ahead and calculate our variance. And so what we need to do is we need to create a table with all the parts and pieces in the equation. So our first column is going to be our x's, all of our data points. Our second column, we're going to write in the mean. Our third column, we're going to do x minus the mean. And then on our last column, we're going to have x minus the mean squared. So first I'm going to write in the mean for each of these. So I'm going to have 20 going all the way down, and we calculated that on the previous slide. Once I have those in, then I can simply subtract across. And so I can kind of put a little minus sign right here in between each of these x's and the mean. And so I'm going to have 15 minus 20 is negative 5, 16 minus 20 is negative 4, 18 minus 20 is negative 2, and so on. And so I'm going to fill in that column to get all of them in. And then I'm going to square the number that is here, the x minus the mean. So negative 5 squared is 25, negative 4 squared is 16, negative 2 squared is 4, and so on. And we continue down until we get to the bottom. So all of these will end up being positive numbers, which will allow you to add them together. And that's part of the reason why we square it, so we can get a positive. So then if you recall, our equation for variance is the sum of x minus the mean squared divided by n minus 1. So what I'm going to do is I'm simply adding up this column. So I'm adding 25 plus 16 plus 4 plus 1 plus 1 plus 0 plus 1 plus 9 plus 16 plus 25. And that's going to give me a total of 98. And so my sum of x minus the mean squared is 98. So now I can plug that into my equation and solve for variance. If I'm going to plug in my sum of x minus the mean squared into the equation for variance, I'm going to start by writing out my equation. Variance equals the sum of x minus the mean squared divided by n minus 1. And so I've already calculated that top part as being 98. And I'm going to divide by 10 minus 1 because 10 is my n, and I'm going to subtract 1. So I have 98 divided by 9, which is going to give me 10.89. So my variance then is 10.89. So that's the average amount that each data point varies from the mean. So how do we interpret variance? Well, in most cases, the variance is simply a step towards finding the standard deviation, so you don't usually need to interpret the variance alone. It's hard because there's no real ruler to measure it against. We know that 0 is low, but infinity is high, and so it's hard to kind of make that distinction. So I won't actually ask you to interpret the variance. Instead, I will always ask you to move on to the next step, which is calculating standard deviation. So standard deviation is really interesting because it is a way to create standard scores out of the data. So what's so standard about standard deviation anyway? Well, what we know is that we have this curve. So everything is based off of this normal curve. We talked about the normal curve when we were talking about skewness, when we talked about the mean. And what makes it normal is that the mean, median, and mode are all the same, and they're all in the center, which means that if we kind of fold this curve in half, we're going to have mirror images. We have the same amount here as we have here. So what standard deviation does is it takes what we know about the normal curve and kind of gives everything a reference point in relation to the mean. So a standard deviation is how far away, either up or down the chart, our data point is from the mean. And so standard deviation tells us that 68% of all responses in a normal distribution are going to be within one standard deviation of the mean. So in this kind of red shaded area, 68% of respondents are going to be in there. We know that 95% of all respondents are going to be within 2, or actually 1.96 standard deviations of the mean. So kind of this bigger, broader area here. And then we know that 99% of all of respondents are going to be within 3, or actually 2.58 standard deviations of the mean. And so only this little tiny bit is not within 3 standard deviations of the mean. This is going to be really helpful later on, and you'll see where we're going to use the standard deviation later in the semester. So then how do we calculate standard deviation? The equation for standard deviation is the square root of the sum of x minus mean squared, or divided by n minus 1, which is also the square root of variance. So we just take the square root of the variance that we found previously, which is 10.89, and that's going to give us a standard deviation of 3.3. So our standard deviation is 3.3. So again, what I did is I took the square root of variance, which we already found, and then that gave me my standard deviation. So how do we interpret standard deviation? Well, we interpret it in relation to the normal curve and those characteristics that we know about the normal curve. So we would say 68% of responses are between 16.7 and 23.3. So basically we took the mean, 20, and we subtracted 1 standard deviation, and then we added 1 standard deviation to get the ends of that kind of continuum, or that block. Normally in this we would also include our metric, so I think here if we're talking about age or number of hours doing something, we want to also make sure to mention that. But that's how we would interpret standard deviation. And that concludes our measures of dispersion.